Now student, come to the chapter number 11, that is the dual nature of radiation and matter. Now the discovery of the cathode rays by the Roentgen and discovery of the electron by the J.J. Thomson, one important milestones in the study of the atomic structure. First of all, we talk about the electron emission. Electron emission होते क्या है? We know that the metals have the free electrons. Metals के पास free electrons होते हैं, हमें मालूम है already. The free electron cannot normally escape out of the metal surface. जो free electron होते हैं, वो metal surface से normally बाहर नहीं निकल जाते. If an electron attempts to come out to the metal surface acquires a positive charge. अगर इलेक्ट्रॉन बाहर निकल जाते हैं metal surface पे, metal surface के, तो जो metal होगा उसके ऊपर कौन सा चार्ज आ जाएगा बच्चों? पॉजिटिव चार्ज आ जाएगा. नाउ दिस पॉजिटिव सरफेस हेल्ड इलेक्ट्रॉन इनसाइड द मेटल सरफेस. नाउ कम टू द वर्क फंक्शन. व्हेन वी गिव द एनर्जी टू एन इलेक्ट्रॉन in the metal, it can come out of the metal. Okay, this minimum energy, I am talking about the minimum energy required by the electron to escape from the metal surface is called what? Is called the work function of the metal, and it is generally denoted by phi, and the value of the phi is h mu naught, and it is measured in electrovolt. Now come to the electron volt. That is, what is the electron volt? 1 electron volt is the energy that is gained by the electron when it has been accelerated by the potential difference of 1 volt. You have to learn this definition, it is very important one. Now the 1 electron volt, that is equal to 1.602 into 10 to the power minus 19 joule. This unit of energy is commonly used in the atomic and nuclear physics. Now come to the different type of electron emission. First one is the thermo-ionic emission. In this emission, the electrons can come out of the metal surface if the heat energy is given to the metal. Next one is the field emission. By applying a very strong electric field of the order of 10 to the power 18 volt per meter to the metal, electrons can be pulled out of the metal. Okay, now next one, that is the photoelectric emission. This is the important one for us. When the light of suitable frequency incident on a metal surface, electrons are emitted from the metal surface, and these electrons are called the photoelectrons, and this phenomena is called the photoelectric effect. Now come to the photoelectric effect. Okay, in photoelectric effect, first of all we discuss about the Hertz observation. The phenomenon of photoelectric effect emission was discovered by Heinrich Hertz in 1887. Heinrich Hertz observed that when light falls on a metal surface, जब light metal surface से fall होती है, electrons escape from the metal surface. जो electrons होते हैं वो metal surface से escape out हो जाते हैं. Now come to the next one, that is Hallmark's and Lenard's observation. Okay, now William Hallmark and Phillips Lenard investigated the phenomenon of the photoelectric emission in the detail. Okay, उन्होंने कुछ experimental setup लगाए थे. The experimental setup consists of two metal plates. First one is cathode, another one is anode inside the evacuated glass tube as shown in the figure. जब next slide से figure आने वाला है उसको देखेंगे हम. Now they observed that the current flow in the circuit when emitter plate C was illuminated by ultraviolet radiation. It means that when light incident on the metal plate, electrons are emitted. These electrons move towards the anode and results in current flow. Now they also observe that when light, then when a negatively charged zinc plate is illuminated by UV light, it becomes a chargeless. Okay, chargeless हो जाता है. Now he also observed that uncharged zinc plate become positively charged when it illuminated by the UV light. जब हमने उसको UV light से illuminate किया था तो वो positively charged हो गया था. From these observations they conclude that the particles emitted carry negative charge. जो particle emit हो रहे हैं वो कौन सा charge carry कर रहे हैं बच्चों? Negative charge carry कर रहे हैं. Now come to the threshold frequency. This is the important one. The minimum frequency V0 required to produce the photoelectric effect is called the threshold frequency, or you can say this is the minimum frequency. Okay, it depends upon what? Upon the nature of material. Now come to the experimental setup of photoelectric effect. Okay, experimental setup में अभी आपको diagram भी देखने को मिलेगा. This is the experimental setup. Okay, you can see here, this is the photosensitive plate, this one. Okay, this is evacuated glass tube. Okay, this is the quartz window, this one, this is the source. Okay, now this is the connection, this one is the commutator, this is the microammeter, this is the voltmeter, this is the rheostat, this is the cell. Okay, you have to learn this diagram. Now students, when UV light is incident on the cathode plate, the microammeter indicate the current in the circuit. जैसे UV light fall होती है तो microammeter जो होता है बच्चों वो current indication start कर देता है show करना. Now when the anode is made negative with respect to the cathode, the current decreases. Remember one thing, it will be decreases at a certain voltage, that is V0, and current is completely stopped, and this voltage V0 जहाँ पे current stop हो रहा है is called the stopping potential. Okay, now come to the formula, that is half mv square equals to ev naught. Okay, this is the kinetic energy, or you can say this is the energy of the electron. Okay, where Bv max is the maximum kinetic energy of photoelectron. Now come to the effect of intensity of light on photo current experiment. Light की intensity का क्या effect पड़ता है? In this experiment, the collector A is maintained at the positive potential. जो collector A है उसको हमने positive potential provide किए, maintain करवाया. The frequency of the incident radiation and the accelerating potential are kept at fixed. जो फ्रीक्वेंसी रखी हमने किसकी, इंसिडेंट रेडिएशन की और एक्सेलरेटिंग पोटेंशियल की, वो हमने बच्चों क्या करी है, फिक्स रखी हुई है. देन चेंज द इंटेंसिटी ऑफ द लाइट. ओके, हमने सारी चीजें फिक्स कर दी. अब हमें बस क्या चेंज करना है, इंटेंसिटी ऑफ लाइट, एंड मेजर द फोटो इलेक्ट्रिक करंट इन ईच टाइम. हमें करना क्या बच्चों, इंटेंसिटी चेंज करनी है, और जिस इंटेंसिटी चेंज करने के बाद हमें बार बार फोटो करंट को मेजर करना है. Now you can see the observation. This graph show that the photocurrent increases linearly with the intensity of incident light. जैसे जैसे हम लाइट की इंटेंसिटी को बच्चों इंक्रीज कर रहे हैं, तो इस ग्राफ में बच्चों आपको साफ दिखाई दे रहा है कि फोटो करंट की वैल्यू भी linearly क्या हो रही है, इंक्रीज हो रही है. Now come to the conclusion. The photocurrent is directly proportional to the number of photoelectrons emitted per second. It means this implies that the number of photoelectrons emitted per second is directly proportional to the intensity of the incident radiation. Now the next one, the effect of potential on photoelectric current experiment. Okay, potential का क्या effect पड़ता है? Again we have to keep the plate A at positive accelerating potential, then illuminate the plate C with the light of fixed frequency and fixed intensity. अब बच्चों यहाँ पे इंटेंसिटी और फ्रीक्वेंसी हमें फिक्स रखनी है, बिकॉज हमें यहाँ पे वेरी क्या करना है, पोटेंशियल को वेरी करना है. देन वेरी द पॉजिटिव पोटेंशियल ऑफ प्लेट ए ग्रेजुअली एंड मेजर द रिजल्टिंग फोटो करंट ईच टाइम. नाउ व्हेन द फोटो करंट रीचेस मैक्सिमम, द पोलैरिटी ऑफ प्लेट्स आर रिवर्स्ड एंड thus apply a negative potential, retarding potential to the plate A. Now again the photocurrent is measured by the varying the retarding potential till the photocurrent reaches 0. जब तक photocurrent 0 नहीं होता तब तक retarding potential को vary करते हुए इस experiment को हमें करते रहना है बच्चों. The experiment is repeated for higher intensity I2 and I3 and keeping the frequency fixed. Okay, frequency fix रखते हुए इस experiment को हमें करना है बच्चों. Now what we will observe? We will observe that as the accelerating potential increases, photocurrent also increases, and at the particular anode potential photocurrent reaches the maximum value, and further increase in accelerating potential does not increase the photocurrent. And when we apply a negative potential to A, जब हम negative potential apply करते हैं A को, the photoelectrons get retarded and hence the photocurrent decreases at the particular retarding potential. Now the saturation current is found to be larger at the higher intensity. Why? Because the photocurrent is directly proportional to the intensity, and but stopping potential is same for the different intensity at the fixed frequency. That is, we can say for a given frequency of the incident radiation, the stopping potential is independent of its intensity. So you can see the diagram, so you can see the graph, and you have to learn the graph also. This is the stopping potential, this is the variable intensity I1, I2, I3, where I1 is less than I2 and I2 is less than I3. This is the photocurrent. Okay, you can see here, if we vary the intensity, the stopping potential does not change. It is same for every stopping, it is same for every intensity of the light. This is your retarding potential and this is your collector plate potential. स्टूडेंट द मैक्सिमम वैल्यू ऑफ फोटो करंट इज कॉल्ड सैचुरेशन करंट. ये डेफिनेशन आपको याद रखनी है. द रिटार्डिंग एनोड पोटेंशियल एट विच द फोटो करंट रीचेज जीरो इज कॉल्ड द स्टॉपिंग पोटेंशियल. दिस इज ऑल्सो लर्नेबल डेफिनेशन. नाउ व्हेन रिटार्डिंग पोटेंशियल इज अप्लाइड, only most energetic electrons can reach the collector plate. At the stopping potential, no electron reach the plate. That is, the stopping potential is sufficient to repel the electron with the maximum kinetic energy. That is half mv square maximum, that is equals to ev naught. Now see, the stopping potential or maximum value of the kinetic energy depends only on the frequency of the incident light, not on the intensity. ओके जो मैक्सिमम जो स्टॉपिंग पोटेंशियल और मैक्सिमम वैल्यू जो काइनेटिक एनर्जी है वो इंटेंसिटी पे डिपेंड नहीं कर रही. हमने ग्राफ में भी देख लिया था. हैंस द स्टॉपिंग पोटेंशियल इज सेम फॉर द डिफरेंट इंटेंसिटी एट द कांस्टेंट फ्रीक्वेंसी एंड एट द जीरो एनोड पोटेंशियल. बच्चों कितने एनोड पोटेंशियल पे? जीरो पे. द फोटो करंट इज नॉट जीरो, दैट इज द फोटो इलेक्ट्रिक इफेक्ट टेक प्लेस इवन इफ एनोड पोटेंशियल इज नॉट अप्लाइड. यानी क्या होगा बच्चों? फोटो इलेक्ट्रिक इफेक्ट हमें तब भी देखने को मिलेगा जब हम एनोड पोटेंशियल अप्लाई नहीं कर रहे हैं. नेक्स्ट वन, इफेक्ट ऑफ फ्रीक्वेंसी ऑफ इंसिडेंट रेडिएशन ऑन द स्टॉपिंग पोटेंशियल. नाउ अगेन एक्सपेरिमेंट सेटअप. In this experiment, we adjust the intensity of light at various frequency, say mu1, mu2, mu3, such that mu1 is less than mu2 is less than mu3, and study that the variation of photocurrent with the collector plate potential. Now we will observe the graph. Okay, that is the collector plate potential, this is retarding potential, this is the photocurrent. If we change the frequency, that is mu1, mu2, mu3, such that mu1 is less than mu2 and mu2 is less than mu3. ओके आपको दिख रहा होगा यहाँ पे हर जगह पे स्टॉपिंग पोटेंशियल हर एक फ्रीक्वेंसी के लिए बच्चों अलग अलग है. बट सैचुरेशन करंट यानी जो सैचुरेशन करंट आ रहा है तीनों ही केसेस में वो क्या हो रहा है बच्चों? सेम आ रहा है. इट मींस फॉर फ्रीक्वेंसी mu1, mu2, mu3, mu1 is less than mu2 is less than mu3, the stopping potential are found to be V03 that is greater than V02 that is greater than V01. It means that stopping potential varies linearly with incident frequency for a given photosensitive material. So the graph of stopping potential with frequency. Now you can see there is a relationship, there is a linear relationship between the frequency of the incident radiation and the stopping potential. Okay, you can see here. Okay, for the metal A, for the metal B. Okay, where mu is greater than mu naught and here the mu is greater than mu naught dash. Now the graph show that the stopping potential, that is mu naught, varies linearly with the frequency of the incident radiation for a given photosensitive material. And the next one, there exists a certain minimum cutoff frequency, that is mu naught, for which the stopping potential is 0. Now these observations have two implications. First, the maximum kinetic energy of the photoelectron varies linearly with the frequency of incident radiation, but it is independent of its intensity. Okay, now the next one, the frequency, that is mu of incident radiation lower than the cutoff frequency, that is mu naught. No photoelectric emission is possible even if the intensity is larger. And third one, we can also say that for a frequency mu naught, no photoelectric emission is possible even if the intensity is larger. Okay, you can say this one is a combined one. Okay, so this minimum cutoff frequency mu naught is called the threshold frequency and it is different for the different material. Now come to the laws of photoelectric emission. This is very important one. For a given frequency of the radiation, the number of photoelectrons emitted is proportional to the intensity of incident radiation. Next one, the kinetic energy of the photoelectrons depends on the frequency of the incident light, but it is independent upon the light intensity. It means ये frequency पे तो depend कर रहा है but intensity पे depend नहीं कर रहा है. Now the photoelectric current does not occur if the frequency is below at a certain value and the minimum frequency, that is mu naught, is required to produce the photoelectric effect, and this is called the threshold frequency. You have to learn this term, that is what is the threshold frequency. And the come to the photoelectric effect is an instantaneous phenomena. This is the instantaneous phenomena. ओके, व्हाट इज इंस्टेंटेनियस फिनोमेना कि जैसे लाइट पड़ी वैसे ही इलेक्ट्रॉन्स, फोटो इलेक्ट्रॉन्स एमिट होना स्टार्ट हो गए होंगे। ओके, ऐसा नहीं कि टाइम लग रहा है। ओके, दैट्स व्हाई इट इज एन इंस्टेंटेनियस फिनोमेना। नाउ द फोटोइलेक्ट्रिक इफेक्ट एंड द वेव थ्योरी ऑफ द लाइट। अकॉर्डिंग टू द वेव थ्योरी, when the intensity of the incident wave increases, the kinetic energy of electron must be increased. Okay, now this is against the experimental observation of the photoelectric effect. Okay, अगर हम बात करें वेव थ्योरी की, तो जो इंटेंसिटी ऑफ द इंसिडेंट वेव होता है अगर वो हम इंक्रीज करते हैं तो काइनेटिक एनर्जी ऑफ इलेक्ट्रॉन होगी वो भी इंक्रीज होनी चाहिए। ओके, वो भी इंक्रीज होती है, बट ये क्या है बच्चों, जो हमने ऑब्जर्व किया फोटोइलेक्ट्रिक इफेक्ट में उसके अगेंस्ट में है ना। अकॉर्डिंग टू द वेव थ्योरी, द एब्जॉर्प्शन ऑफ एनर्जी बाय द इलेक्ट्रॉन टेक प्लेस कंटिन्यूअसली। ओके, एंड द लार्ज नंबर ऑफ इलेक्ट्रॉन absorb energy from the wave at a time. Hence, the energy received by the single electron will be small, and hence it takes hours to eject an electron from a metal surface. बहुत टाइम लग जाता है इसको मेटल सरफेस से इलेक्ट्रॉन को इजेक्ट करने में। This delay photo emission is against the experimental observation. ओके, अब ये जो डिले फोटो एमिशन हो रहा है ये भी एक्सपेरिमेंटल ऑब्जर्वेशन के बिल्कुल अगेंस्ट में है। नाउ स्टूडेंट, कम टू द आइंस्टाइन्स फोटोइलेक्ट्रिक इक्वेशन। ओके, फर्स्ट ऑफ ऑल एनर्जी क्वांटम ऑफ द रेडिएशन। आइंस्टाइन एक्सप्लेन दैट द फोटोइलेक्ट्रिक इफेक्ट बेस्ड ऑन द क्वांटम थ्योरी, एंड अकॉर्डिंग टू द क्वांटम थ्योरी द लाइट कंटेन फोटोन्स having the energy h mu, and when a photon of energy h mu incident on the metal surface, electrons are liberated. ओके, इलेक्ट्रॉन्स लिबरेट होना स्टार्ट कर जाते हैं जब एच म्यू एनर्जी के फोटॉन्स उसके ऊपर फॉल होते हैं। अ स्मॉल पोर्शन ऑफ द फोटॉन्स एनर्जी इज यूज्ड फॉर द वर्क फंक्शन। जो छोटा सा पोर्शन होता है फोटोन एनर्जी का वो एक तो वर्क फंक्शन में यूज में आता है, और जो बाकी पोर्शन होता है बच्चों वो काइनेटिक एनर्जी ऑफ द इलेक्ट्रॉन्स में यूज में आ जाते हैं। बाय द लॉ ऑफ कंजर्वेशन ऑफ एनर्जी, photon energy that is equals to work function plus the kinetic energy of electron. Now put the values. The photon energy denoted by the h mu, work function is phi, kinetic energy is half mv square. It means half mv square equals to h mu minus phi. This is the equation number 1. If the threshold frequency mu naught is incident, we can take the kinetic energy equals to 0. So equation number 1 जो होगी बच्चों वो क्या हो जाएगी, 0 equals to h mu naught minus phi. It means we can say that phi equals to h mu naught. Now this is the equation number 2. अब हमें क्या करना बच्चों, इस इक्वेशन नंबर 2 को इक्वेशन नंबर 1 में सब्स्टिट्यूट कर देना है। इट मींस वी गेट हाफ mv स्क्वायर इक्वल्स टू h mu माइनस h mu naught। थोड़ा सिंप्लीफाई करते हैं, हाफ mv स्क्वायर इक्वल्स टू h ब्रैकेट स्टार्ट mu माइनस mu naught। दिस इज इक्वेशन नंबर 3। दिस इज द आइंस्टाइन फोटोइलेक्ट्रिक इक्वेशन, एंड बट वी नो दैट mu equals to c upon lambda, so that mu not equal to what, that is c upon lambda naught. Now substitute these value in equation number 3. इन दोनों वैल्यू को हमें कहां पुट करना है बच्चों, इक्वेशन नंबर 3 में। Now after substituting we get the formula that is half mv square equals to h bracket star c upon lambda minus c upon lambda naught, and half mv square equals to sc 1 upon lambda minus 1 upon lambda naught. Now discussion, explanation of the photoelectric effect on the basis of Einstein photoelectric equation. Okay, now if the intensity of the light increases, light intensity अगर हम increase करते हैं, more number of photon interact with the electron and more number of electron are emitted, thus the electric current increases with the intensity of incident light. Now the next one, for a given metal phi naught that is equals to h mu naught is constant, and hence from half mv square that is equals to h mu minus h mu naught we can write here, we can understand that kinetic energy depends upon the v. Okay, that is the incident frequency. Now from this equation that is half mv square equals to h mu minus h mu naught, we can understand that the photo emission is not possible if mu is less than mu naught. Now come to the fourth one. According to the quantum theory, the photon interacts with the single electron to sharing of energy take place. Okay, now it means there is no sharing of electron takes place. Okay, this one, so that there is no time delay in photoelectric emission. Now the next topic, that is your particle nature of the light, that is the photon. हम photon की बात कर रहे हैं। The photon picture of electromagnetic radiation is as follows. अगर हम photon की बात करें तो उसके कुछ features हैं, उसको देखते हैं। In interaction of the radiation with the matter, the radiation behave as if it is made up of the particles called the photons. next one, each photon has the energy, that is E, and the momentum, that is P. Now photon energy is independent of the intensity of the radiation. जो photon energy होती है बच्चों वो light की radiation पे depend नहीं करेगी, independent रहेगी. That is the photons are electrically what? Electrically this is the neutral and not deflected by the electric and magnetic field. Now in a photon particle, the collision, the total energy and the total momentum are conserved. Now come to the students, wave nature of matter. In 1924, the French physicist Louis Victor Broglie put forward the hypothesis that moving particles of matter should display a wave-like particles, or you can say wave-like properties under the suitable conditions. Okay, the waves associated with the material particles are known as the matter waves. Okay, now or you can say the de Broglie waves. इस matter wave को हम de Broglie waves भी बोलते हैं. Now the de Broglie wave is seen with the microscopic particles like proton, electron, neutron, etc. Now the wavelength of matter wave is called the de Broglie wavelength, that is lambda equals to what? That is h upon mv, where h is, this is your Planck constant, m is the mass of the particle, v is the velocity of the particle. Now the next one students, wavelength of the matter waves. हम लोग wavelength कैसे calculate करेंगे? Now the energy of the photon we already know, that is equals to h mu. Okay, now this is your equation number 1. Now if the photon is considered as particle of mass m and the energy of the photon can be written as, that is equals to mc square, very famous Einstein equation, that is equals to what? Mc square. Now from the previous equation and equation number 2 we can write down that h mu equals to mc square. Now simplify this one, we get m equals to h mu upon c square, this is our equation number 3. Now the momentum of the electrons can be written as p equals to mass into velocity. Now put the value of the mass, okay, and we know already the velocity. Now we have to what? We have to substitute the equation number 3 in equation number 4. After substituting, we get that p equals to h mu upon c square into c. Simplify करने के बाद बच्चों अपन को h mu upon c मिलेगा. Okay, and after simplifying, we can convert the c upon mu, that is equals to lambda. So we get p equals to h upon lambda, or you can say lambda equals to what? That is your h upon p. Now come to the wavelength of electron wave. Okay, if electrons of mass m and charge E is accelerated through a potential difference. कितना potential difference रखना बच्चों? V volt. The de Broglie wavelength can be written as, that is lambda equal to h upon under root 2 MeV, or you can say that lambda equals to under root of 150 upon under root V, because we know the value of the Planck constant, mass of electron, charge of electron. इनको value को जब put कर देंगे तो ये value इतनी आ जाएगी बच्चों, that is under root of 150 upon V angstrom. Now come to the uncertainty principle. According to the principle, it is not possible to measure both the position and the momentum of an electron at the same time exactly. Okay, हम लोग momentum और position exactly same time पे calculate नहीं कर सकते. या तो आप momentum calculate कर सकते हो या फिर position. If del x is the uncertainty in the position and del p is the uncertainty in the momentum, then the product of uncertainty is given by del x into del p, that is equals to h upon 2 pi, where h is already, that is your Planck constant. The above equation allows the possibility that if del x is 0, अगर del x की वैल्यू 0 है तो del p must be infinite in order so that the product is non-zero. Okay, और इसका vice versa, अगर आपका del p 0 है तो del x तो आपका infinite होना चाहिए. Similarly, if del p is 0, del x must be infinite. Okay, you can see the graph. This is the wave packet description for del p equals to 0. The above wave packet description of matter wave correspond to a definite momentum, okay, and of an electron extend to all over the space. Okay, इसका momentum जो रहेगा वो बिल्कुल definite रहेगा, वो change नहीं होगा बच्चों. Okay, next one, in this case del p equals to 0 and del x equals to, या फिर you can say that is del x tends to infinite. So student, this was your chapter number 9, 10 and 11. I hope आपको तीनों चैप्टर के वीडियोस जो रिवीजन पार्ट के वीडियो से अच्छी तरीके से समझ में आ गए होंगे. इन वीडियोस को बार बार देखना और जो वीडियो हमने प्रीवियस केस में अपलोड कर रखे हैं उन्हें भी बार बार देखना और एनसीईआरटी बुक को अच्छी तरीके से गो थ्रू कर लेना. ओके, थैंक यू.